Hi, Kai. Today, we're going to talk a little bit about some new architecture changes to Tailpipe.
We are. A fairly big change, actually. So Tailpipe, as it stands at the moment, um, creates Parquet files directly and manages those files. We've now moved over to using a new technology called DuckLake, which has been developed by DuckDB. DuckLake's a new lakehouse format. Sure,
I
absolutely.
like the idea of a lake house. Can we all get lake houses?
So yeah, what a lakehouse is it's a combination of a data lake and a data warehouse. So it's basically file storage, which has got database features to help you manage the metadata. So this is ideal for what we want to do within Tailpipe. So within DuckLake, all the data is stored as Parquet files, which is what we were doing before. That gives you efficient storage. It's stored by column. But there's also a separate metadata database that tracks all the Parquet files and tracks a whole bunch of statistics about those files, schemas, partitions, transactions. And we can now interact with that data in a transactional fashion. And yeah, so it's got a bunch of advantages. Yeah, it provides a structured, query-friendly way to deal with the data. So before we were really kind of bare metal doing conversion code into Parquet and reading the Parquet files, and that works very well. But it is nice to have that extra layer of abstraction to give you more, information about what's going on and more control.
One of the things I think that this helps us with, and we'll dig into the architecture a little bit more in a minute, is really more flexibility in partitioning, right? In Tailpipe, we had partitions built a certain way, and we have a little more flexibility in how we can partition with Tailpipe now with DuckLake. Yes.
Yeah, this is one of the useful things actually. So with Tailpipe, we would partition by the partition, by an index, and by a date field. But the data itself has also a timestamp field. With Parquet, it can be very efficient in figuring out which Parquet files you're querying from with DuckDB rather.
Mm.
And it uses partition columns to do that. Um, but what this means is if you want to make use of that efficient file selection, then ideally you need to have the date field, specifically TP dates in our data, in your query where clause. But it's likely you're also going to want TP timestamp, the timestamp field in your where clause. So what that means is to get efficient queries, you sometimes find yourself needing to do a where on date and timestamp, which is just a bit, a bit awkward and a bit ugly. What DuckLake has is a feature where you can partition the data by a function. So we can partition the data by the month of the timestamp. And then if you use the timestamp in a query, it will automatically deduce which partitions correspond to that timestamp. And so you can now just query, just filter on the timestamp. So that tidies up your queries quite a bit.
That's fantastic.
I mean, other benefits that it gives you, we're building on top of an existing platform. So DuckLake is being very actively developed by DuckDB. We're seeing fixes and developments, ongoing. So we can really get leverage by sitting on top of that rather than just implementing it ourselves. There's, a really good active team working on this project. It's got a lot of momentum. And it feels really good to be part of, to be honest, and to be able to kind of, sit on the back of that work and it works really well. And it feels like a good foundation for what we're doing. This is how it works at the moment. It's pretty simple. So this is specifically looking at how we query the data. We have a bunch of Parquet files. When you collect the data, it creates those Parquet files. Those are all stored partitioned within a partition folder structure. And then we have a DuckDB, and that DuckDB just has views on those Parquet files. And then when we're querying, you connect to that DuckDB and you use those views to query. So it's very simple and it works fine. Not drastically different what we're going to. The only difference here is there are actual tables now. So
Mm.
there's now a metadata database, which is the DuckLake database, which is SQLite database. That actually defines tables for each of the partitions that you've collected. So now you can query those tables directly. And the metadata database links the Parquet files to the tables. So we don't directly access Parquet files anymore. We're just querying the database, and then the DuckLake engine will figure out what Parquet files to query for us. So from a user perspective, very little difference, except you're sitting on top of this rather more capable platform. But under the covers, it's a lot more efficient.
Very transparent change to users, but we're building a lot of future capabilities and really building with DuckDB and that whole team and all the great stuff that they're building. So I'm excited to see what capabilities this is going to end up unlocking in Tailpipe in the future.
Absolutely, yeah. There's a bunch of stuff in there that's going to be very useful, moving forwards. DuckLake handles schema evolution. Let's say you've got transactions, you've got rollback. Um, depending on what engine you use for the metadata database, you can have multiple writers. So this really lays the groundwork for when we move Tailpipe into pipes.
Thanks for watching, folks. If you're ready to get started with Tailpipe, you'll find more information and a getting started guide at tailpipe.io.